Okay, let me start recording this. Today's lesson, assume you have watched up to lesson 3. If you have not watched lesson 3, watch that first, lesson 3 from announcement 3. Then after you finish watching that one, then watch the recording for this. Now, today we will learn review 4 topics that we being covered in part of lesson 2 that I didn't do last week, and lesson 3. Okay, most of lesson 3. Okay, there will be some little part from lesson 3 that I won't be able to cover. I will see. Okay, I will try to cover most of them, but you will see by the end of today, this is the nice thing. By the end of today, by the end of this lesson, you would be able to do most problems from my past test 1. Okay, and in fact, all the problems, just like last week, problems that I will bring up here, the examples that I bring up here will be from my old tests. The one from last week actually from my old quizzes, but the one we will do today will be from last test. Now, the first topic is constructing frequency distribution. Constructing frequency distribution from raw data. Okay, I will use an example from my old test. Okay, but the procedure will be pretty much like this. Okay, the first step, we will need to find the range, which is the maximum data minus the minimum data. Let me pick one problem from the past. Give me a second. Let me use this one. Give me a second. Enlarge that a bit. Okay, I hope we still can see it. Okay, so suppose this problem, this is from which semester? Let me see. From spring 19. This is from spring 19, math 227. I believe that's from ELAC. Test 1. And the first 9 question is related to this data. But we will do the one of the problem there is to construct frequency distribution. Okay, now the first step is to find the range. Let me do from this example here. From this example here, the range is, the maximum is 104, the minimum is 18. Can you see that, by the way? I do it here. So the one on the left is to remind us the procedure. The one on the right will be the application of that procedure into this example. Now, and then second, find the class width. Find class width, usually denoted by lowercase w. Now, lowercase w is the ceiling. Okay, it's not a bracket. It's not a bracket. A bracket looks like this. This is a bracket. Okay, but no, we are not using bracket. We are using ceiling. Ceiling is basically a bracket, but without the floor. Without the floor. Okay, now ceiling means rounding up. You round up, okay? So that's the range over number of classes. Number of classes. Now, this number of classes in my class, when you take my class, the number of classes is always given. And in fact, every teacher who asks you to construct frequency distribution will always need to tell you the number of classes. There's actually a formula, two different formulas that commonly used to decide how many classes we should use, but we will not use that formula, okay? Yeah, we will not use that formula. We can though, but the thing is like that assumes you know how to use logarithm, but that prerequisite has not been applied for this class, right? So I cannot really expect you know how to use logarithm. Coming back to this example, suppose we want to construct a frequency distribution with, let's say, 4 classes. Now then, the class width for this example will be, what is the range again? That will be 86, right? That's the range, okay? So the class width will be the range, which is 86, divided by number of classes 4. Okay, that's 21.5. That's the ceiling of 21.5. Okay, now ceiling means we round up. Ceiling means we round up. Always round up. Even if this were 21.3, you still round it up. Even if this is 21.03, you still round it up. Okay, always round up. Always round up. Now here, 21.5, if we use regular rounding, that's still 22, right? But even if that were, again, even if that were 21.4, we still round it up to 22. Are you with me? Now, we round it up to the nearest integer, and that's the commonly used notion, because the number here are all in integers. Okay, the numbers all here in integers. Now, once you see decimals, then you can round it to integers also if you want. But you can also round it to 1 decimal place. Okay, preferably though, for our class, just round it to the nearest integer. Okay, for our class, just round it to the nearest integer. But later on, I will give you an example where you can round it to the nearest 0.5, right? Not to the nearest, to the next 0.5, or to the next 0.1. You can do that. Okay, so this notation here, suppose this notation actually means round to the next integer. But for the purpose of the accuracy in our class, it may also means round to the next 0.5, or round to the next 0.1, or round to the next 0.4. That's also okay. Now here I round it to the next integer first. Now, once we are done with the class width, then the third step is set the lower class limit of the first class, the lowest class, as minimum. Actually, I think I should say set the minimum as lower class limit of the first class. Set the minimum as the lower class limit of the first class. So in this step 3 here, let me move it a bit to the left. And now in our step 3 here, when I start working on my frequency distribution, okay, let's say this is the score. We should have 4 classes, right? Now, the lowest class limit of the first class will be the minimum 18. This is the minimum. That's what I said to be lower class limit of my first class. Okay, now then, next, add the lower class limit by the class width to get the next lower class limit. Do this repeatedly until we get the number of classes needed. So from that 18, I will add the class width, 22, that becomes 40. So you add 22, the class width, you add 22, the class width, to get the next lower class limit. Okay. And you keep on doing that until you have enough classes. We need 4 classes, right? So I will add 22 again for the next lower class limit, add 22 again for the next lower class limit. Are you with me? Now, yeah. Remember, the class width is defined to be, the difference between consecutive lower class limit. At least that's the definition used in our textbook, and that's the definition used by a lot of textbooks. Okay, now the actual class width, definition of class width is actually slightly different. Okay, it's actually slightly different definition, but the outcome is always the same to this computation. Okay, that's why for now we just follow what our textbook says. Okay, which is not wrong, but that's not the actual meaning of lower class limit. Okay, now, so remember, the class width is not the following. It's not like 18 and then you add 22, then it becomes the upper class limit of that class. No, that's not right. Okay, that's not right. What we learned from last week, lower class class width is defined to be the difference between consecutive lower class limit, not the difference between lower class limit and upper class limit. That's not true. Okay, that's about class width. Now then, so I have 4 classes already right now, right? Now then, how do we find the upper class limit? Now the upper class limit will be done in the following way. So this is the first class is 18 up to what? 18 up to one number less than 40. So I use 39. Why one number, Thomas? Because remember we rounded to the nearest integer, right? If we round it to the nearest integer, then I will subtract one unit, one integer from this lower class limit to get the previous upper class limit. Okay? Because I rounded to the nearest integer, so I subtract the next lower class limit by 1, which is the rounding that we use, to get the previous upper class limit. That's how we get that 39. Now then, so let me write it here, part C. The first upper class limit is the second lower class limit minus 1. And y1, in this case, I clarified, depends on the rounding we use in number 2. Okay, in number 2, we round it to the nearest integer. Then what I do here, we subtract 1 integer lower. Okay, if in step 2, I round it to the nearest 0.4, then what I do here, I will subtract by 0.4. Give me a second. Now then, from that upper class limit 39, we do the same procedure again. Okay, we do the same procedure again. We add the class width. Okay, we keep on adding the class width. And you will see that it's basically this guy subtract by 1. Okay, I add 22 again. That will be 83, which is this guy subtract by 1. Okay. Now the thing is, the last upper class limit should be done the same way. Should be done the same way. You still add class width. Okay, so if I add the class width, that will be 105. Not the maximum 104. No, no. The number you get here should be equal to that number or more. The number you have here should be equal to the maximum or more than the maximum. Okay, so it's not like this. It's not that the last upper class limit has to be equal to the maximum. No, it doesn't have to. It doesn't have to. Maybe more. Okay, how do we know, Thomas? Well, as long as you follow the procedure, you just keep on adding class width, adding class width, adding class width. Now, most students actually understand what I do here from the previous test, right? Of course, the one who don't study, they don't know even how to start. Okay, but for those who study, most of them, they know what to do. But if they make any mistake, they usually make mistake here. Some of them still have that notion that the last upper class limit has to be the same to the maximum, which is not true. Not true. Okay, that's not true. Okay, what you need to do to get that last upper class limit is by adding class width again. That's how you do it. Okay, that's how you do it. Now, so let me write it there. Then add that upper class limit by W to get the next upper class limit. Do this repeatedly until we get upper class limit for all classes. Okay, now that's the setup. Okay, the last step, you can call that step 4. We do the tally. Okay, basically we look at the frequency. Okay, so the frequency, okay, look at that data. The first class is from 18 to 39 to here. So that's the first class. How many of them? in my test, I always try to arrange that in order, and for each column, I try to make it exactly 10. Of course, you need to count it first though. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So one column is 10. This is up to here only. So how many of them? In the first class, they are, the frequency is 8. Now then, for the second class, from 40 to 61 up to here. The third class from 62 to 83. Okay, and the last class from 84 all the way up. Then when you see, can you tell me the second class from 40 to 61, how many people there? I have 9 students right now in this class. I don't know how many of you actually working together with me. Yeah, 14. Okay, thank you. Now, how about from 62 to 83? So I know each column is 10, right? So from here to here is 10, to here is 20. So there will be 23, right? That would be 23 for the third class. And then the last class will be, I believe that's 13. Okay, thank you. Now then, after you're done, you add this. Always, every time I ask you to do frequency distribution, every time you deal with frequency distribution, you always need to add them, always. Now, let me add this here. So what is this? This is 58. Okay. Now, then once you get this 58, make sure you check your original data, make sure that they are 58 data. 10 times 5, that's 50, plus 8. Then yes, there are 58 data. Then now you are done with this constructing frequency distribution. Okay. Any questions so far? No question? Let me make this a bit smaller. Okay, so that's the procedure. The one on the left-hand side is the procedure. The one on the right-hand side, to the right of the yellow color, is the example. Do you think you can replicate this on your own? Now, let me give you one example for you to work on. So I assume you already copied that down. Okay, let me ask you to do this problem. So example 2. Example 2. Let's say we have this frequency distribution. Let me enlarge that. Okay, and then let me ask you to construct a frequency distribution with maybe 5 classes. Construct a frequency distribution with 5 classes. Do you think you can do that? I mean, I'm thinking to give you 5 minutes to do this. Would you like to try? Okay, let me give you 5 minutes to do this. Right now it's 8:47. We will come back at 8:50, let's say 8:53. Okay, please do that. Okay, so this is the framework. Okay, I want you to do that later on. But you see that the first example and second example, I show you purposely the test score we get from, I get from my previous class. The test one scores from my previous elementary statistics class. So I did say that my test one supposed to be the easiest, right? But I still have students actually doing poorly, like the one here. You know, I don't know why. I honestly don't know why. I don't know why. You know, and of course they wonder why. Usually they hang out together in class, so they actually talk among themselves. Thomas, why the test score is so bad? But when they spoke that loud, students who get this score usually hang out together also. They basically just turn their heads and look at them. It's like, what are you talking about? You know, like 4 of us get one more than 100. You know, so it's just like, hey, well, you know, I let you guys talk to each other instead of me need to defend myself. Why this class not doing well? I mean, you just look at people around you. You sample from the wrong people. Okay, you only ask your friends and you think the whole class must have the same score with you. No, that's not true. Okay, after this guy found out that there are people who get more than 90, and when this guy found out there are people get less than 20, they actually surprise each other. Huh? Somebody get more than 90? Huh? Somebody get less than 20? What the hell are you doing? That's what happened, you know. So I want you to do this. Okay, make sure you know this though. Okay, make sure you know this, because after the test, if you don't do well and you talk to your friend, very likely you'll be surprised. Okay, and I don't want that to be happening. I want that to be a good surprise for you. It's like you get 100 and then you think you're doing so well and it turns out somebody else getting 100 also. Then that will be a good surprise, right? Okay, yeah, let me give you 5 minutes from now. The range is 102 minus 4, that's 98. So 98 divided by 5 is, what's that?
19.6.
19.6, and we will round it up, right? Okay. Because I rounded to 0.5 here, so you can round it to the next 0.5. Okay, if you want to. Okay, you can round it to the next 0.5, which will be 20. You can also round it to the next integer, which happens to be also 20. Okay, but my point is this. If you round it to the next integer, like the one here, if you round it to the next integer, then when you do your class width here, you add 20, right? You add 20, you add 20, you add 20, 5 classes. And then because you round it to the next integer, then you subtract that 24 by 1, becomes 23. You see what I mean? 44, and then you keep on adding 20. But if you use the rounding to the next 0.5, if you round the next to the next 0.5, then from this 24, you will subtract 0.5 instead. Okay, so depends on which rounding you use, even though both of them in this case end up with 20, right, the class width. But if you round it to the next unit, then you subtract by 1 unit here. But if you round it to the next 0.5, then there you will get subtract 0.5. Can I clarify how I get the number of classes? That is given. That is always given in my class. That is always given. I mark it here. The number of classes will be given in my class. Okay, so in my question, I will tell you how many classes you need to construct. Is it okay? Okay, okay. So the number of classes will be given to you. There is actually a formula to do that, okay? But that formula involves logarithm, which I know now is not the that's actually something you learn in Algebra 2. However, that is not a prerequisite anymore for this class, right? So expecting you to know how to do logarithm, especially if you don't have a calculator that TI-84 yet, then it may be difficult to do. Okay, that's what I said earlier, and that's what I said just now. Okay, so I will tell you how many classes you need to construct. Okay, now then come back here. I will round it to the next unit. Okay, I will round it. I expect that's what you did earlier. I will round it to the next unit. So after I get those 5 classes, lower class limit for 5 classes, then I subtract by 1, I subtract by 1, subtract by 1, subtract by 1, subtract by 1. And then when I add 20, this will be 103. Are we going to learn how to use calculator? This one, you cannot use calculator. I'm not teaching you how to do log because that's what your Algebra 2 teacher is supposed to do. Okay, so no, I'm not teaching you how to use logarithm. Okay, but I will still just give you I will tell you how many classes you need to use. Okay, will I teach you how to use calculator to do this? Unfortunately, no. Calculator cannot do this. Your calculator cannot construct frequency distribution for you. So you have to learn to do it by yourself. Okay, so will I teach you how to use, will we going to learn how to use the calculator? I will teach you how to use calculator, but not for this one because your calculator cannot do this one. Okay. And of course, I don't expect you to wait until I teach you how to use calculator, then you will start learning it. Okay, if things can be done using calculator, I would just teach you how to use calculator, but then you don't know what it means, why it's like that. Okay, this class is elementary statistics. This class is not using calculator for elementary statistics. No, it's not. Okay, so don't focus too much on calculator. It's like calculator is not smarter than you. That's a big principle. Okay, calculator is not smarter than you. If you know nothing, then your calculator cannot do anything for you. Okay, so no, not the calculator. The compute and the computation we did here is actually quite simple, I believe. Right? Okay, we learn how things works behind it. Okay, such that even without calculator, especially in this case, calculator cannot do it. Okay, you still can do that. Okay, Microsoft Excel can do frequency distribution for you, by the way, but if I need to teach you how to use Microsoft Excel to do frequency distribution for you, it will take approximately 2 weeks just to teach you the coding. Okay, just to teach you how to code it. You know, it's not that simple. And yes, this class is not Excel for statistic either. Okay, now let me come back here. I'm done with the framework for the classes. Now I see, I start doing the tally. So the first class 4 to 23, and then 24 to 43, 44 to 63, 64 to 83 up to here, and then 84 to 103. So the first class will be how many people? There will be 15. The second class from 24 to 43, there are 10. From 44 to 63, there are 15 again. 64 to 83, they are 20. And then from 84 to 103, they are 13. Let me add how many people here. I get 73. Do we have a total of 73 people? That's 10 times 7, 73. Yeah, that's right. So we have 73 people confirmed. Now, that's how we do it. Okay. Now, what if, Thomas, what if we round it to the nearest 0.5, next 0.5 instead? Yeah, in this case, I will still get the class width is 20. But then you will see this is what happened. You will see this is what happened. Score, the frequency, this will be 4, 24, 44, 64, 84. This will be 23.5. At 20, at 20, at 20. From the previous upper class limit, I keep on adding 20. Papa. Okay, and then you will see, strangely, that the frequency will, I mean, you can see that again, though, it may be different, but I believe from the numbers I saw there, happens to be the same again. I will get this again. If I round it to the next 0.5. Okay, now, but I don't really like this one. I don't really like this one for you, okay? In practice, it's possible. In practice, it's possible we do it this way. But one of the steps that we will do later on is to extend this frequency distribution to find, let's say, the mean. Now, if you have 0.5, then the midpoint will be quite ugly, right? And then when you square it, it's uglier, you know. Okay, yeah, that's what happened. That's what happened. So it's, yeah, if in the test, if you want to do it this way, fine. I mean, I will accept that. Can I round it to the nearest 0.1, Thomas? I don't really suggest you to do so because it's already 0.1 here. Okay, so if you round it to the nearest 0.1, it will be 19.6, or you may prefer to use 19.7. Okay, now, but if you do so, you will see later on that your mean and standard deviation will not be too far different from whoever did it this way anyway. Now, if that's the case, what's the point of making it too accurate, okay, if the result will not be that much different anyway? Okay, that's why if you ask me in your test, round it to what? Just round it to the next integer. Okay, don't need to do it this one. So we have done two examples here. We have done two examples in constructing frequency distribution. One, I did it myself for you. And then the second one, I hope you did it yourself. Okay, now that's pretty much the first part of the lesson today. Next, I will put things together. Now I will put things together. What do you mean by put things together? In my test ones, number 1 to number 9 are related. Starting from a raw data, given. Okay, then I will ask, you need to find the mode, the median, or maybe the median first and then the mode, the first quartile, the third quartile, the range, and then construct frequency distribution, and from that frequency distribution you extend to get the lower class limit, upper class limit, lower class boundary, upper class boundary, relative frequency. And then you will also extend to find the mean, variance, and standard deviation. And then finally, you will need to find usual interval and outliers. Now, what I meant by putting things together, basically, I put everything we learned from the beginning until now into these 9 questions. Okay? If you miss anything, then you won't be able to finish these 9 questions. Okay, now let's start. Suppose I go back to that one example. This one here, the one we just did. Okay, suppose that we have this one. Let me put the boundary. Now then, the first question, question 1, what is the mode? What is the most frequent data here? There are a lot of numbers happen twice, but is there any number happen 3 times? Only 93. Only 93 happened 3 times, right? Only 93 happened 3 times. Nothing happened 4 times. Oh, no, 93 and 100, actually. Oh, wow, I almost missed it. And 51. Wow, 51 happened 3 times also. Okay, so what's the mode? Because we have 3 modes, then in my class I say, if you have 3 modes, you will say no mode. You may want to explain a little bit, that's trimodal case. So some teachers will call that trimodal case and want you to list them 51, 93, 100. But in my class, I accept only up to 2 modes by model. Okay, next. Now, the second question. Find the median. Let's see the position of the median first. There are 73 data as we computed earlier, right? Plus 1 divided by 2, that will tell us the position. 74 divided by 2, that's 37th. Data number 37th is the median. So this is the first 10, 20, 30, 1, 2, 3, 4, 5, 6, 7. So my median is 61. Exactly one number. Okay, because the median is exactly one number, and that's the median is data number 37. It means in the lower half, has how many data? How many data below that median, not including the median? The lower half has 36 data points. Okay, now that gives us the road to compute the position of the first quartile. The first quartile will be located at the 36 plus 1 divided by 2 position. That's 18.5 data. So what is data number 18.5? 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. It's in between. It's in between. So the first quartile will be 33 plus 37.5 over 2. That's 35.25. Now, likewise, for the third quartile, that will be data number 18th and 19th together. We already have 3 plus 10, that's 13, 14, 15, 16, 17, 18, and 19 in between. Okay, so the third quartile will be 76.5 plus 77 divided by 2. That's 76.75. Any questions so far? Thomas, can I just put all these numbers here into the calculator and then find the first quartile? I don't recommend you to do so. How do I get the third quartile? The same way you did the first quartile, but you do it from the top. The way I did the first quartile, see, that's data number 18.5, right? So that's between data number 18 and data number 19. I count it from below. Now, to get the third quartile, you count it from above. 3 plus 10, that's 13, 14, 15, 16, 17, 18, 19. Okay, so data number 18 and 19 from below, in this case, will give us the first quartile. From above will give us the third quartile. Okay, now, by the way, you can also count it this way. You can also count it this way. Let me erase all of these. You can also count it this way. You can count it from here. You see that 61.5 is in the upper half, right? So from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. Still 76.5 and 77. Okay, so either you count it from the next number after the median, Or if you count it from the top, data number 18 and 19 will still be these two numbers. Okay, so I need to, you need to ask yourself, when you say, how did I get it? Did you don't know how to actually do it at all? Or if you don't know where to count from? Okay, now if you don't know where to count from, just count it either way, you will still get the same number. In this case, the same pair that you need to get the average. Okay, you will get the same pair that you need to get the average. Okay, but I did get that question though, Thomas. Where do we count it from? Like the first quartile, you count it from below, right? Why the third quartile, you count it from above? Well, because the third quartile is the second half, the upper half anyway, right? And because that's the halves, right? The position is right in the middle, means if you count it from below, this is 18.5. If you count it from above here, you will see this is also 18.5. Because what? It's in the middle. It's in the middle. It means the distance from the lower, the bottom, or the distance from the top will be the same. Okay? Yeah. Now, the student who asked me that question, Thomas, you were not clear where you count it from. I said, well, tell me what you think. Well, I thought you count from above. That's what that person said. I said, then just count it from above, then what you get. And when he counted from above and get the same thing, so I went back to him as I said, did you actually count it? Okay, so when you say, I thought I counted from above, but you didn't do it anyway, you know, that's for that person. Okay, now, that's why I want to say that as long as you know how to find the first quartile, you apply the same idea to the third quartile, you will get it anyway. Okay, now the best way is, of course, you count it from above when it comes to the third quartile. Okay, but you will see if you put these numbers here in order, these two pairs will be right in the middle of the whole upper half. Okay, now that's for the quartiles. Let me mark it again. So this is the median, right? Use this formula to know the position. Okay, n plus 1 divided by 2, right? Now, because it is exactly one number of the data set, then the lower half must be there only 36. So from 37, there are only 36 data. Okay, now then 36 data in the lower half, you add 1 divided by 2, you get 18.5, means the quartile, the first quartile is located between data number 18 and 19. It's right in the middle here. Likewise, if you count it from above, it will be data number 18 and 19 from above. Then the first quartile will be the average of these two numbers. The third quartile will be the average of these two numbers. Okay. Now, please practice this, because if you use calculator to do this, first, it will take you too much time. Second, you won't be able to show this work anyway. Okay, you won't be able to show that work, and you will miss the easy question mode, which you can just do it by looking at that. Next, the third question, the fifth question is find the range. The fifth question is find the range. So you need to know what the range means, but the range is always the maximum minus the minimum. 102 minus 4, that's 98. Question number 6. Construct a frequency distribution construct a frequency distribution with, earlier using this data, we construct with 5 classes. Let's say this time construct a frequency distribution with 4 classes. Let's say we do it with 4 classes. We already know the range is 98. So how about the class width? If I tell you to do it in 4 classes, that will be 98 divided by 4. I wonder what's that. It's 24.5. That's 24.5. If I round to the next unit, that will become 25. I always need to round it up. Now, therefore, what happened with my frequency distribution? What happened with my frequency distribution? So the scores and the frequency, the first lower class limit is the minimum number, which is 4. 4 plus 25 is 29, plus 25 is 54, plus 25 is 79. Now, because I rounded to the nearest unit, then the first upper class limit will be 1 less than that 29. And then I keep on adding the class width, adding the class width, adding the class width. Now let's do the tally. 4 to 28. 4 to 28, 29 to 53, 54 to 78, 79 to, 78. Now the thing is, this 78.5 is right in the gap though, later on. Right? It's right in the middle. See, that's the boundary. Right at the boundary. Now, if it is right at the boundary, you count it in the next class. Okay, you count it in the next class. If it is right at the boundary. If it is right at the boundary. So 79 to 103. Okay, so the first class has how many people? There will be 16. The second class from 29 to 53, that is 15. From 54 to 78, that's 26. Let me count right. So from here, 10, 21, 2, 3, 4, 5, 6, 26. And then the last one is, so that's 10 plus 6, 16. Now I add these. Let's see how many people. 18 plus 3, 23, 2, 73. Oh yeah, it should be 73. So I don't miss anything. So that's for our question number 6. Construct frequency distribution with 4 classes. Now let's see the next question. Let's see the next question after that. The next question after that will look like this. The next question after that will be number 7. And that's 7 points for that question, which means you should be able to do that in at most 7 minutes. Copy the frequency distribution in number 6 below, and then extend it. So the first instruction is to copy that. You need to know frequency distribution means these two columns. Don't do any extension here. I only ask you frequency distribution. That's frequency distribution. Okay, that's frequency distribution. Now, question number 7 has the instruction, copy that first. Okay, copy that first. So I will copy that. And later on, I know I will extend it. So let me just make it like this with 4 classes. This is the score. Start from 4 and then 29 and then 54, 79, that's 28, 53, 78, 103. The frequency will be the 15, as I remember, 15 as well. 16, 15, 26, 16, the total of 73. That's the copying. Now then you need to extend this to find the lower class limit, upper class limit, lower class boundary, upper class boundary, and then relative frequency. Now we did this lower class limit, upper class limit, lower class boundary, upper class boundary last week toward the end of the class. It's like, I think the last half an hour of that class. The last half an hour of that class. Okay. I hope you remember that, but let me just do this one. Let me just do this one. Let me do this one to remind you in case you forget the terminologies, right? Lower class limit is always the lowest number registered by the interval. Okay, so that will be 4, 29, 54, 79. The upper class limit is the largest number registered by that interval. That will be 28, 53, 78, 103. Now, how about lower class limit, upper class limit? Okay. The upper class limit of the first class is the average of these two numbers. It's in between. Okay, that will be 28.5, right? 28 plus 29 divided by 2. Okay, and the next upper class limit is the average of these two. The next one is the average of these two. Okay, so this will be 53.5, 78.5. And the nice thing is the upper class limit for the first class is low. I'm sorry, upper class boundary of the first class is also the lower class boundary of the next class. So they share the same fence. They share the same fence. Okay, so imagine these are the classes. Right? This is 4, 28, this is 29. Then the boundaries between. Okay, now then you see that from upper class limit to upper class boundary, that's 0.5 units. Now using that idea, then you extend to the left, give you the lower class boundary for the first class. So you subtract 0.5, you get 3.5 here. Using the same idea, you get 103.5 here. How about the relative frequency? The relative frequency is the frequency for that class divided by the total frequency. That's the relative frequency. Okay. And in my class, I don't mind you to leave them in fractions. Okay. I don't mind you to leave them in fraction. Just make sure that for the relative frequency, the same with frequency, you need to add them. Okay. And make sure you show that's equal to 1. However, if you want to make it into decimal, make it 5 decimal places. In real life, usually only 4. Okay, or if you make it in percentage, then it will be 3 decimal places in the percentage. So if you change this into decimal, it will be 0.21918. Don't forget the leading zero. Don't forget the leading zero. Remember that leading zero, okay? If there's no integer part to the left of your decimal point, then you need to put that leading zero. Now I go on. This happens to be the same, so let me just copy that down. Okay, 15 over 73 is 0.20548. And 26 over 73 is 0.35616. Okay, so this is for number 7. It's more about your understanding on what this means and apply that to the frequency distribution you already get earlier. So if you get this frequency distribution, what will the lower class limit for each class? What will the upper class limit for each class? What will the lower class boundary for each class? What is the upper class boundary for each class? And what is the relative frequency for each class? Okay, now that's for number 7. Any questions so far? No question. Okay, I go on with question number 8. Question number 8. Give me a second. I copy the question from number 8. Question number 8. Copy the frequency distribution you get in number 6 below. So you basically do the same thing first. You copy the frequency distribution. And later on, you will extend it to find the estimated mean, variance, and standard deviation. Now, round your final answer on only final answers to 3 decimal places. Usually, if I don't say how far you need to round it, then assume it's 5 decimal places. Okay, so what I will do first now is to copy the frequency distribution. Or I happen to remember that. Upper class limit. And then the frequency, that's 16, 15. I remember that's 16 here. That's 26 here. Let me check just to make sure. Yeah. So therefore, I get 73. Now then, we need to extend this to find the mean. We need to extend this to find the mean. So how to find the mean? We did this extensive work of this last week. We have group data interval right now, right? This is frequency distribution with interval type. Okay, so to find the mean and the variance standard deviation, the first step you need to do is to find the midpoint. Okay, I hope you remember that. From the midpoint, you multiply that by the frequency. Then from there, you square the midpoint. And then multiply by the frequency. Do you remember this from last week? Okay, now then, let me ask you to do this. Okay, basically you will see this will be your first number, this will be your second number, this will be your third number, and this is a sample, I believe. Yeah, we consider this as a sample. Okay, that's a sample. So basically find the sample means, sample variance, and sample standard deviation. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Let me give you 10 minutes from now. Let me give you 10 minutes from now, and then let's say around 7 minutes from now, I will start working on this. Okay, but let me ask you to remind yourself how to do this. I hope you still remember. Okay, like this one here is the midpoint 4 plus 28 divided by 2. That's 16. Now this one here is frequency times the midpoint, that's 256. This one here, the midpoint being squared happens to be 256 also. And this is 16 squared. This is 16 times 16. And this will be 16 times 256, which I don't know what's the number. Do we do sample or population? Anybody can help me? Did we will we do this as a sample or population? Yeah, if you see the recording I showed you earlier, that consider this as a sample. Okay. Yeah, from the question, it specifically say consider this as a sample. So we will do it as a sample. Okay, let me give you 10 minutes. So this will be, what is this? 41. And then 66. and then 91. Is it right? Okay. Before I go on, notice that the class width is 25, right? So it starts from this one, you add 25, add 25, add 25. And the way we set it up, I subtract by 1 to get that 28, add 25, add 25, add 25. Now, then one of the big consequence is that once you get the midpoint for the first class, you will add 25, add 25, add 25. Okay, you can also do that 29 plus 53 over 2 to get you 41. You can, but if you want a shortcut, that's the shortcut. So this statistician who designed these procedures here, they have in mind to help you doing things faster. Okay? Okay. If you follow the procedure, if you follow the procedure. Oh, by the way, I forgot to mention one very important thing. Remember I told you about the class width? Remember I told you about the class width? It should be 53.5. Remember I told you about the class width? Right? Now, the class width originally defined as, in our textbook, they call that the difference between consecutive lower class limit. Okay? The actual definition of class width is the difference between lower class boundary and upper class boundary. I'm sorry, that should be, that's right, that's 3.5. Yeah, that's the difference between lower class boundary and upper class boundary. That's the actual definition of class width. Okay, if you subtract this, you will get 25. Okay? In other words, the class width is not the difference between lower class limit and upper class limit. No, it's not. That's not the definition of class width. The definition of class width is supposed to be the difference between lower class limit, lower class boundary, and upper class boundary of the same class. Now, however, for people like you just barely start, then they tell you slightly difference to make it easier for you. Okay, so they tell you that the class width only the difference between consecutive lower class limits. Okay, that's what they tell you. Okay, but that's actually not what it is originally. Okay, now let's go on further. I will need to compute all this here. So 15 times 41 is 615. Let me compute all of these first. It's 1,716, 1,456 plus 716, 615, 256. I get 3,043. Anybody get the same thing? Nobody get the same thing? Well, anyway, now then the sample mean X bar will be the second number divided by the first number. Okay, 3,043 divided by 73. So the average is, no, it won't be. Am I adding something wrong? Oh, I'm sorry. Yes, I typed 716 instead of 1,716. No wonder nobody said yes. So it should be 4,043. Did I fix it right now? Okay. Now, you may wonder about this. So Thomas, earlier you wrote 3,043. You didn't find that that's anything wrong with that. When you divide by 73 and you look at your calculator, then you see something wrong. How do you figure it out? I figure it out this way. This is how I figure it out. Notice that this frequency distribution is approximately symmetric, right? And we have more number here compared to this. So the average is supposed to be in this number, between 54 to 78. I mean, I use my gut feeling. It's supposed to be between 54 to 78. It won't be 41. It won't be 41. Okay, so that's why I look at that. No, it must be something wrong with my computation from the smell test, right? Okay, so that's why it's like, hey, you know what, something wrong. I look back to my calculator. Hey, you know what, I add something wrong there. Okay, that's how I figured it out. Okay, now then 4043 divided by 73 give me 55.38356. Okay, that's the average. Now then, xi squared, 41 squared is 1681 multiplied by the frequency 15, give me 25,215. 66 squared will be 4,356 multiplied by the frequency 26. That's 113,256. And then 91 squared is 8,281 multiplied by 16 give me 132,496. Then I will add all these numbers. I hope I don't type anything wrong anymore. I get 275,063. Therefore, my sample variance, do you get the same number, by the way, for the third number? If not, tell me what you get. In case I make mistake again, I hope not. Do I make any mistake? Well, I will go on. Okay, I will go on. Now then, this will be 73 times 275,063 minus 4,043 squared. You got the same number? Okay, thank you. I wonder what's the... I know usually Ludin also follow. Ludin, where are you?
Here, yeah.
Do you get the same number, Ludin?
I haven't check on it yet, so sorry.
Okay, or do you need more time? If you need more time, I give you more time.
Okay, sorry.
No, you don't need to say sorry. I may be too actually earlier. I purposely give you guys extra 3 minutes. Okay, but if you need more time, fine. This is the first time you do it.
Okay.
Yeah. Let me give you 3 more minutes then. Let me give you 3 more minutes. Okay, let me continue. So we get the sample mean already earlier, and then for sample variance, I get this. Don't forget the denominator is not 73 squared for sample variance, it's 73 times 72. Then when I compute this, yeah, during the 3 minutes I gave you, I compute it, I get this number. such that the sample standard deviation would be 26.65293. Okay, now I did this problem earlier with the other class, I think, and at that time I think I asked them to do 5 classes instead. So the consequence was that the variance is a little bit smaller than this. The variance, I think it was like around 20. I think the variance was around 23 or 22. I don't remember precisely. Okay, but now we are done with this sample standard deviation. Now let's go on to the next question. The last question for this topic is, from that number 8, find what is the interval within twice standard deviation away from the mean, and list the outlier. So for the usual interval, we need to do the lower fence, or lower bound, sometimes we call that. That's the mean minus twice standard deviation. The upper bound or upper fence, that's the sample mean plus twice standard deviation. Now, if this were population, then accordingly it will be mu plus twice sigma. Okay, so you just adjust that. Oh, I just need three decimal places, huh? Okay, round the final answer to 3 decimal places, remember? So I will use these, and I will use this. Okay, so then when I compute this is 55.384 minus 2 times 26.653. What's that? I get 2.078. And then the upper bound will be, we add twice standard deviation instead. I get 108.69. So the usual interval in interval notation is 2.078 to 108.69. That's the usual interval. Now, how about the outlier? Now you will compare this interval from 2.078 up to 108.69. Compare with the original data. Compare with the original raw data. Okay, let me grab the original raw data and copy that down here for us to see better. In a second. So we compare with the original data. Let me put it here. Okay, now you see that the smallest number 4, the minimum number 4, the minimum is in this interval, right? 4 is here. The maximum is also in this interval. So all the data is actually in this interval. So if that's the case, then no outlier. Okay. Why? Because all the data that we get here, all of them are in the usual interval. Now, suppose we change the usual interval. Let's say the usual interval turns out to be 10.7 to 101.2. Let's say that's the usual interval. Okay, let's say that's the usual interval. Then you imagine that interval 10.7 to 101.2. Compare that with the original data. Which data are not in this interval? Start from 10.7. So start from 10.7 at 11 all the way to 100 are in the usual interval, right? Okay, so the outliers will be these numbers. The outliers will be this number. Then you just list all of them. The outliers are 4, 5, 6.5, 7.5, 9, 102. You see what I mean? Okay, outliers is defined to be those data points that is not in the usual interval. Okay. Let me erase this. Now I want you to replicate what I did here, this big project, to the next question. Draw a big line here to separate. Okay, let me ask you to do the following question. Give me a second. Let me ask you to do this question. How many minutes for this? Oh, hold on. These are not 10. There are only 8 here. So this is 8 data here times 5. That's 40. There are 43 data. Okay. Not the column is not 10. The column is not 10. Okay. How many minutes for this? Can I give you like 10 minutes for this? Maybe. Yeah, 10 minutes from now. So 10:30. Maybe, yeah, together with our little break. So 10:35 plus 10 minutes, 10:45. So we come back at 10:45. You are done with this. Okay, 10:45, you are done with this. And if you happen to just want to go on with question number 7, question number 7 is you copy that and then extend it to the lower class limit, upper class limit, lower class boundary, upper class boundary, and the relative frequency. Okay, in case you want to go on. But I prefer you to do this first and then take your 10 minutes break. Try to do this in 10 minutes. Don't worry about number 7. Okay, we come back at 10:45. So there are 43 data. So the median is 43 plus 1 over 2. That's the 22nd data. So data number 22 will be, that's 8, 16, 24. So data number 22 is this. So the median is 62.5. How about the mode? I saw 82 is the mode. Is it right? 82 is the mode. Okay, great. And then because data number 22nd is the median, means there are 21 data points in lower half and upper half. Now then 21 plus 1 over 2, that's the 11th data. Oh, nice number. Okay, nice number. So the 11th data, 8, 9, 10, 11. That's 47.5. Data number 11 from the top will be 78, huh? It will be 78. The range will be the maximum data minus the minimum. That's 82.5. No, we don't round the range. We don't round the range, okay? We don't round the range. We don't round the range. So data number 11. Okay, now then create a frequency distribution with 5 classes from above. So the class width will be the range 82.5 divided by number of classes 5. Then that will be 16. Oh, 16.5. That's 16.5. So I will use 17. Okay, therefore, the scores will be, the minimum is 11 plus 17 is 28 plus 17 will be 45 plus 17, that's 62. I wonder if I'm making a mistake. Why I feel like I'm making some mistakes. Yeah, 80 divided by 5 is 16. Yeah, okay. So this is 27, this is 44, this is 61 plus 17 will be, that's why I feel, oh, 5 classes, no wonder, my bad. So plus 17, that will be 79. No wonder I feel like something not right. 5 classes, not only 4. So plus 17, this will be 78 plus 17 will be 95. Okay, so the frequency from 11 to 27, 11 to 27, the cutoff is here. From 27 to 44, the cutoff is here. And from 45 to 61, the cutoff is here. And then from 62 to 78, the cutoff is here. And then 79 to 95. Okay, good. So the first class has 6, second class has 4. This is 6, this is 4. The third class is 10. The third class is 10. The fourth class is 4, 12, 13. And the last class is 10. I add this 10, 13, 43. Yes, we have 43 data. So we are good now. So that's for question number 6. Let's go on with question number 7. Question number 7 is copy the frequency distribution in number 6 above. Give me a second. Copy the frequency distribution in number 6 above, and then construct the upper class limit, lower class limit, upper class limit, upper class boundary, lower class boundary, and relative frequency. Can I ask you to do this in 5 minutes maybe? Is it doable in 5 minutes? Okay, 5 minutes. Okay, so we start again at 10:58. Yeah, number 7. These are actually quite easy. I believe these ones are quite easy. Okay, this is the frequency distribution, lower class limit, upper class limit, lower class boundary, upper class boundary, relative frequency. That's 11, 28, 45, 62, 79, 27, 44, 61, 78, 15. So I get this is 27.5, the same to this. This is 44.5, the same to this. 61.5, the same to this. 78.5, the same to this. Okay. And then the upper class boundary for the top one is 105.5. Lower class boundary for the bottom one is 10.5. Relative frequency, this will be 6/43. Yes, in my test, just leave it as fractions. Yeah, but however, if later on you go to work or somebody asks you to do it like at your work context, right? Or in your higher course, the senior year project, for example, then make it into 3 decimal places at least. Okay, in decimal, at least 3 decimal places. Usually 4 decimal places. But in my class, you can just leave it like that and make sure you add them. Okay, and make it equal to 1. Okay, that's for number 7. Are you done with this? Now, if you are done with that, we go on with the next part where I want you to compute the mean and variance and standard deviation. How did I get 105? Oh, I'm going a second. I'll copy that down first. I'm in the middle of copying that. How did I get 105? This one here? Is that your question? Oh, should be 95. Thank you. Should be 95. Should be 95. I added wrong. Sorry. Yeah, should be 95. I copied it wrong. 95, 95. I copied it wrong. I'm sorry. So 95 here. This is 95.5. Thank you. I copied it wrong. Is it okay right now? Then we will go on with copying that frequency distribution again, but this time we will find the mean, variance, and standard deviation. This one, consider this as population. In the question, it says consider this as population. Okay, so let me ask you to copy that. I believe if you did this problem on your paper, then you already have that, right? Okay, let me copy that here. The scores 11 plus 17 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 plus 17. The frequency will be, I remember 6, 4, 10, 13, and 10, I believe. Okay. Now the thing is, that data is from population. Now you need to remember how to extend this table though, to find the mean. And variance and then standard deviation. To find the midpoint first. And then multiply the frequency by the midpoint. And then xi squared. And then fxi squared. Now the thing is, the heading here is something you need to memorize in the test. Okay. Now the good thing is you have that. I allow you to have a cheat sheet, right? So I assume you have some printout of my old solution, so you can see. Some people, they don't even know after they have the heading, they don't know what those heading means. That's actually one of the big questions. Let me give you 1, 2, 3, 4, 5, 6, 7, 8, 9 minutes from now. Let me give you 9 minutes from now. So that will be 11, 13, maybe 11, 14. Okay, please do that. If you're not done, you can just continue working, you know. Okay, so this is 38 divided by 2 is 19, plus 17 will be 36, plus 17, 53, plus 17, 7, plus 17, 87. Okay, so 6 times 19 is 114 here, 144, 530, this is 910, this is 870. So when I add them, this is 8, 8, 9, 16, 3, 8, 16, 25. 43. So the population mean mu will be 2,568 over 43. I get 59.7 to 3 decimal places, 7 to 1. X squared is 361, 36 squared, 1,296 times 4, 1,100. 1,166, 53 squared, 2,809 times 10 is 2,000, 28,090. 7 squared should be easy. That's 4,900 multiplied by 13. 63,700. This is 70,569 multiplied by 10. That's 75690. And 10, 15, 24, 33, plus 13, 18, 16, 17. Let me check with my calculator, just in case I make mistake. Yep, that's what I get also. On calculator, so the population variance will be the population size times sum of fx squared minus the sum of fx being squared over 43 squared, because this is population variance. And then that gives me 499.22445, which square root the standard deviation, population standard deviation will be 22.343 to 3 decimal places. Now, my question to you is, do you, any of you get the same thing? Any of you get the same thing?
Yeah.
Okay, great, good. Okay, 2 of you, good. Then let's continue once we get that. And the last question from this part is, from this number 8. From this number 8, what is the interval with 2 standard deviations of the mean? What is the interval with 2 standard deviations from the mean? And then list the outliers. Let me ask you to work on that. Okay, and then for the outliers, we will only need to compare that with the data, original data, right? The problems we do here is from Sp21, test 1. This is from Sp20 for last semester, Math 227 at East LA College, test 1. Then I hope you remember how to do this, but let me just do it. So lower fans or lower bound is the mean minus twice standard deviation, 59.721 minus 2 times 22.343. And then the upper fans will be the mean plus twice the standard deviation, okay. This is equal to 15.3 0.035. Well, this one here, I get 104.407. So the usual interval will be from 15 point something to 104.4 something. But then when you compare with our original data, when we compare to our original data, this guy here are not in the interval, right? Okay, but 20 already in. And on the top, 93.5, it's already in the interval. So from here, we see the outliers. Outliers are 11, 14.5, and that 14.5. Okay, those are the outliers. Okay, so what happened is this. Why then we call that outliers? Basically, when we compare the scores from these 3 students, okay, compared to the whole class, not compared to Thomas standard. No, not compared to Thomas standard. Compared to how the whole class perform, then these 3 students are actually underperforming. Okay, now even though 20, of course, 20, 25, 26, 28, 30, 41, these numbers, of course, bad, right? These numbers are bad numbers. Okay, but they are not outliers. They are not outliers. They are still within reasonable range compared to the rest of the class. Okay, yeah, it's just like that 11, 14, and 14.5. They are more than twice standard deviation away from the mean, and therefore is considered outliers. Okay, now that's for number 9. Now that's basically what we put together for our number 1 to number 9. So I hope during this weekend or during the weekdays, okay, try to spend some time, print out 1 or 2 of my old test 1 and try to work on those, okay, on your own. You can print out the one that I have solution already, so you do it on your own and then you compare to my solution. Okay, now let me go ahead to the next part, that is probability with Venn diagram. Probability with Venn diagram. My assumption, again, you already watched that lesson 3 from announcement 3. Okay, now the thing is, I purposely choose this question for 2020 because question number 10 relates to question number 10 relates to the data again. So what we have on the first page of that test, test, the data. Okay, this is the data, right? Okay, these are the test scores. Now, turns out that in my number 10, I use that again. This is question number 10. Let me show it for you. Yeah, this is question number 10. Okay. No, that's not. The data set on page 1, that's the one I show you above here. The data set, that's the one up here. Okay, contains 14 female students. Okay, and 6 of them took final. Only 19 male students took final. Construct the Venn diagram. How many students there again? 43 students, right? So when I construct the Venn diagram, that Venn diagram needs to total 43 students. Venn diagram always start with a rectangle, always. And then there are 2 categories here. The one that is male or female. Let me use the first circle to be female. Okay, the first circle to be female, which means outside of that first circle will be not female. Okay, I don't need to make two circles, one of them for female and the other one for male. No need, no need. The interpretation will be it's either you female or not female, in this case male. Now the other circle is, do they take final or not? Okay, do they take final or not? Now, according to this passage, there are 14 female students taking in that among that 43. Of these 14 female students, 6 of them took final. So female and final. This is the number of female and taking final. Okay, now this 19 here is the number of male, which I will write as not female and taking final. Six of the female take final, so the 6 is here. Okay, only 19 male students took final, so there are 19 outside of female and take final. If the number of female is 14, how many students did not take final? How many students did not take final? Remember, the total female should be 14, right? So the one inside this circle should be 14. The one inside this circle should be 14. Okay, 6 of them took final, then 8 of them did not take final. But there's still one number missing here, the one outside. That's outside of female circle and also outside of final, right? Okay. The interpretation will be that's the one not female and not taking final. The number of males not taking final. What's the total supposed to be? 43, right? So 8 plus 6 plus 19 plus what equals to 43. It's 33 plus 1. Oh, okay. So there are 10 males not taking final. Any question for now? Okay, no question. So let me go on with part B. Let me go on with part B. Once you are done with that Venn diagram, so Venn diagram actually helps us to summarize the data and organize at the same time. Okay, now a plenty of issue in statistics has something to do with your ability to organize data. I mean, we have a lot of data, like from what we get in our daily life. We have so much data, but then when we try to make decision, we need to be able to sort, to first filter what data is relevant, second, sort those relevant data before we can analyze them. Okay, so that's a skill though, that's a skill. So I did have these students say this to me, some of them actually in sense of complaining, Thomas, the way you give us the data is not clear. It's like when you say this way, I don't know what you're trying to say, Thomas. Why don't you just give us clearly? Well, I tell them, I say, the thing is, in statistics, one thing you learn is to organize data. That's one thing you learn. So of course, the information I give to you may not be organized. You are the one supposed to organize that. Okay, so when you say you are confused, that's because you did not think organizing the information is part of your assignment, part of your job. Okay, but once you realize, oh, you know what, that's what I need to do, well, then you know that's what you need to do. Okay, instead of expecting somebody else to do it for you. Okay, and most of the time though, for example, once you are the director, for example, right, for him to make decision, he will ask his assistants or his staffs to actually gather the data and organize them. Okay, now they cannot make decision. The staffs do not know how to make decision because they don't go as far as, for example, master's degree, but at least they know how to gather the data. Now later on, the director or the manager or the supervisors, the one who will better train, okay, then they use the big data set. Okay, they use the big data set and then use the numbers that already being filtered out, those irrelevant ones already being sorted, then continue with the computation. Okay, now then, so part B, in experiment of selecting a participant from that group at random, write the notation and compute the probability of selecting a male who did not take the final. Notation, probability of selecting a male. Now, using the notation we have in Venn diagram, male is, in this case, defined as not female. So the notation will be probability of not female, outside of female, intersect not taking final. The male who did not take final. Now then, how many students in that Venn diagram who are male and not taking final? Male and not taking final will be 10 out of overall 43 students. Okay, that's the probability. So the probability method that we use here is we assume each of these 43 students are equally likely to get selected. Okay, what is the probability that person is a male and not taking final? There are 10 of them out of 43. Part B, in an experiment of selecting a participant from that group at random, write the notation and compute the probability of selecting a female. So compute the probability of selecting a female or someone who took the final. Either female or take final. That's the notation. Okay, then let's compute. How many females there? There are 14, right? That's 6 plus 8. Or final. So how many people taking final? 6 plus 19, but the 6 already counted. I just need to add 19 more over 43. That's equals to 33 over 43. Okay. Any questions so far? Any questions so far? If no question, then I go on with the next example that I would like you to do on your own. I want you to do the following question, but this is not related to the one we had earlier. So let me give that a long line. It's not related to the question we had earlier. Let me erase this so that it doesn't confuse. A data set contains 73 students. I don't want you to confuse this to the earlier problem. So a data set contains 73 students. We have 44 female. Half of them took final. Now, only 8 male students took final. Let me ask you to first construct the Venn diagram. Second, oh, the same question actually here. Okay, yeah, let me ask you to do this problem 1, 2, 3, 4, 5, 6, 6 minutes from now. So 11:45. Okay, try it. Working on that also, but I hope at least you are done with the part A though. Okay, so construct Venn diagram. Remember, Venn diagram always start with a rectangle. Okay, yeah. Give credit to the person who decide or first invent how to organize the data that way, and his last name is Venn. Okay, if his last name is Thomas, then yes, it's up to me, right? Okay, but no, it's not up to Thomas. It's not Arjuna diagram. Okay, here the question seems to be very similar to the one we have earlier. So we have the group of female and we have the group of people took final. 44 female, half of them took final, means 22 took final. Therefore, the other 22 did not take final. Now, only 8 male students took final. Only 8 male students took final. Now, how many male students did not take final? So 22 plus 22 plus 8 plus what equals to 73? I get 21. 30? I don't think so. Let's see. This is 52. So there are 52 students, either female or final. Right? So that would be 21 students who are male and not taking final. The total has to be 73. Okay, the total has to be 73. Now then, in part A, in an experiment of selecting a participant from that group at random, write the notation and compute the probability of selecting a male. So probability of not female again. Now I use female instead of male because the Venn diagram we use in there is female and male, therefore the one outside of female. Okay, not female. Okay, and N did not take final, so not taking final. How many not female, not taking final? So male not taking final, that's 21 over 73. Okay, but don't forget, I want you to write the notation also beside computing. So this is the notation. That's the notation. Then part B, with the same procedure, write the notation and compute the probability of selecting a female or someone who took final. Female, it's 22 plus 22, there are 24 of them, plus the one who took final, 22 and 8, right? 22 and 8, so that 22 already counted. Divided by 73, we get 52 over 73. Let's do one more problem like this. One more problem very similar to this, but not as similar as that anymore. This one, let me screenshot that. Let me ask you to do this one here. Okay. In a group chosen for a study in a college contains 100 participants with 47 smokers among them. Now, 68 of these participants, of these 100 participants, 68 of these participants have a car, and 35 of them, 35 of these 68, smoke. They construct the Venn diagram. So it's about, do they smoke? Do they have car? Okay, so that's the two circles you will have. Let me give you another 5 minutes to do this. Okay, let me start working on that. If you're not done, just continue working on that. So I have a group of smokers. And then another group of having car. They will have a car. So I will just use notation car. 47 smokers. 68 have a car. Those who have car and smoke are 35. So this is the number of people smoke and having car. This is the number of people smoke. And 68 is the number of people having a car. Okay. So 35 having a car and smoke. Now there are a total of 47 smokers. So how many of these smokers don't have a car? The total of smokers is 47, right? Okay, 35 of them have car. So the remaining 12 that make up 47. Okay, the remaining 12 have no car. While of those having cars, 35 of them smoke, a total of 68. So the other 33, they don't smoke. Okay. When I wrote this question, I don't have any intention whatsoever in mind. I just pick up a case. Okay, but suppose you want to see what percentage of people who smoke having a car, and if they don't smoke, they have car, then from there we may see that, you know what, you want to have a car, you better stop smoking. And I mean, that's one way to do that. And that comment was actually made by a student who is not my student, but that person happened to have access to this test. So that person make a comment, Thomas, is this the way we find out to argue, you know what, one of the benefit of stop smoking is that you have better chance to have a car at the end, or maybe you have a better chance to have a car earlier, Okay, I said, well, I didn't have that intention. For sure, these numbers are hypothetical. Okay, for sure, these numbers are hypothetical. But if you really want to do research there, but yeah, this is one way to look at that. Okay, how do I get that 68? How do I get that 33 from this 68? 68 people have a car, right? So in this circle here, in this set, the total has to be 68. We know 35 of them have a car and smoke, right? So the other 33 have a car and don't smoke. That's how I get that 33. Okay, then, but we are not done yet. Don't forget that we need to also consider the one outside of this. Those people who don't smoke and don't have a car. Don't smoke and don't have the car. So how many people there supposed to be? The total should be 100. 80 plus what equals to 100. So that's how we get that 20. Okay, now then, part B, in an experiment of selecting a participant from that group at random, write the notation and compute the probability of selecting a smoker without a car. So smoker and without a car. How many smokers without car? So this question here, part B, of all these three questions in this part that I show you, for the part B, you need to know how to write the notation and interpret from the Venn diagram. Okay, that's what you need. Okay, that's what you need. So think about, okay, with this picture here, this Venn diagram here, which part talk about smoker without a car? This is the circle for the car. So when we say without the car, it must be everything outside, right? Outside of the car, but inside the smoker. It's this part. Okay, so there are 12 smokers without a car out of 100. Okay, I will convert that to decimal because it is an easy decimal. Don't forget, you still need to write the notation. You still need to write this notation here because I want it. Okay, now part C. In an experiment of selecting a participant from that group at random, write the notation and compute the probability of selecting someone without a car, or non-smoker. Yeah, again, I have to emphasize that please keep in mind that when I write a test, okay, I pick cases, I chose cases, and sometimes, I mean, for sure, the numbers are hypothetical, okay, just for the purpose of learning from there. No agenda to say that to against anybody smoking, against anybody without car. No, please don't think that way. Okay, please don't think that way. You know, not having a car doesn't mean it's bad. No. Okay, even though I personally not a smoker, I have nothing against smokers. Okay, I have nothing against smoker. Of course, if you ask me why you don't smoke, Thomas, it's my personal preference. Okay, my personal preference. Just as much I would like you to respect my preference not to smoke, I also respect your right to smoke. Of course, when we go to the health benefit and financial benefit, it will be more beneficial if you don't smoke, right? Okay, health-wise and financial-wise. But on the other hand, don't get me wrong, that my father-in-law, that's really nice person, you know, I'm so happy. I really think that marrying my wife, I get very good bonuses. did I say bonuses? Like I get a very nice father-in-law that can be, beside being a father that I can respect, but he also can be someone like my friend. Last year, before the birth of my second child, my daughter, he came to United States in January the 1st. And because of the pandemic, my in-laws, my mother-in-law, father-in-laws get stuck at my place here for 11 months. And it became a very nice fellowship with them. Like I know them a lot more. And I'm glad that we get stuck together, you know, like we become very, very nice person. And he's a smoker. Okay, he's a smoker. So nothing against smoker, nothing against smoker. Okay, and not having a car also in some sense nice. Like just to let you know that people in New York, a lot of them they don't have car. Like New York, Manhattan, New York. Okay, a lot of them they don't have car. They say that it's cheaper to live that way. Just go by subway everywhere. And when when I went to New York, then I understand that I like to walk. So basically, if you want to go around Manhattan, walking is actually a lot more convenient than having a car. Okay, that's me. One of my cousins, pretty close to me, did work in Wall Street. And yeah, just speaking about Wall Street, his background is financial engineering, and he did study a lot statistics. Okay, he himself make like 300K a year at that time. Right now, he's already moved to Singapore, being assigned to Singapore. But at that time, he made like 300K a year, and I was surprised he didn't have a car. I said, well, hey, I'm about to go to New York. Like I say, I'm about to go to New York. Will you drive me around? He said, no, dream on. I don't have a car. I said, what the hell? I thought you make a lot of money. I was like, what? And then he said, well, once you come here, then you will understand why I don't need a car. Okay, it's not that I cannot buy a car, but what's the point of having a car here? Okay, and it turns out that his place is like walking distance, like 5 minutes walking distance from Wall Street. And he said, if I have a car, I still need to pay for parking. And trust me, the parking is so expensive there. Well, anyway, that's a little story. Okay, so please don't think that I chose these numbers and I purposely have any agenda. No, please don't think that way. Okay, I just need an example, right? Okay. Now, not having car, how many people without car in this Venn diagram here? The one outside of car are these 12 and 20. Let me write them down. That's 12 and 20. Okay. Or not smoking. The one not smoking are these two, right? But the 20 already counted, so I just add 33. Overall, 100 people, so we have 65 over 100, which is 0.65. Okay, now don't forget, even for this question, I still ask you to write the notation. And when I say I write the notation, it refers to this probability notation. Okay, now that's for this basic Venn diagram. I'm about to give you a break. Okay, when we come back, we will do the following problem. Let me zoom it out a little bit so that I can screenshot that well. Give me a second. Yeah. When we come back, we will do the 3-circle Venn diagram, and you will see this is more complicated. So when we come back, we will do this problem. Let me line this up first. Let me see this as partition, new problem. Right? And let me give you 20 minutes break. Okay, so we come back at 12:30, let's say. Okay, we come back at 12:30. At that time, we will do this problem. Yeah, we have a Venn diagram here, and we need to compute the probabilities for these events. Okay, I think let me just make it a bit smaller so that I can fit them into one screen. Give me a second. I want to fit them into one screen. However, there's one stuff that you need to pay attention here is that I want your final answer to be in simplified fraction. So beside getting the answers, I will also teach you something new later on, how to simplify a fraction using your calculator. Okay, now let's start with this, because this is the thing, like suppose one element is randomly selected from the diagram, only one element. Part A, that notation means what's the probability to get a B. We select one element, right? Okay, so we need to first find how many elements we have in total. How many elements we have in total. I will add all of these numbers, 16 plus 10 plus 5 plus 7. Those are the one in A. Plus the one outside of A but in B, 14 plus 3. Plus the one outside of A or B but in C, plus everything outside. Okay, so I will add these numbers here. I get 100. Oh, nice number. So there are 100 elements. Okay, now so what is the probability of selecting something or one element from B? Then I will see how many elements in B. 10 plus 5 plus 14 plus 3 over 100. When I add them, that's 29, 32, that's 32 over 100. Okay. Because it's over 100, I think it's quite easy to reduce. Okay, here we can reduce by 4, reduce by 4. So that's the probability. Now, let me show you how to use your calculator to reduce a fraction. I think I will just show you once or at most twice. Okay, suppose we want to reduce a fraction. So I have 32 divided by 100. That's the fraction, right? Now, if you want to reduce this fraction, you press math. The third from the top on the left-hand column, press math. Okay, the very first option, that's convert to fraction. This one here. Okay, convert to fraction, enter. Then you will see that 8 over 25. Okay, now let's see part B. Part B, we want to find the probability of selecting somebody in A and C. A and C, the element in A, and also in C, because it is the and, so it has to satisfy both, right? Now it refers to this region here. Okay, it refers to that region. So how many elements in A and C? There will be 7 plus 5, which is 12. Can I just say 12 times? Yes, you can. You can just say 12 over 100, and then you reduce that, right? But if I write 12 there, and you study, let's say, on Sunday, you may wonder where I get that 12. That's why I write that 7 plus 5 first, so that you can restudy from here. Okay, now part C, what is the probability of selecting from B or C? B or C, as long as you count it at least once, you count it in. So B or C refers to this region here. Now, because it is an OR, then as long as it is shaded once, you count it in. Okay, as long as it is shaded one. The one inside of B will be 10 plus 14 plus 5 plus 3. Those are the one in B. Plus the one in C that you have not counted earlier. Okay. In C, we have 5 and 3. Okay, but we count them already. Plus 7 plus 23. Which, if I add them, let me see, what do I get? So that's 24 plus 15 plus 23. That's 62. 62 over 100. Where is... Oh, no, sorry, I saw it wrong. Not 23, 22. Thank you. It's 22. I thought it's 23 earlier. It's 22. Thank you, thank you. Yeah. You may misunderstood my 23 earlier with this 23. No. I saw this as 23. Remember that it was lined up such that I thought it's a 3. Like that. Okay, so no, it's not 23, it's 22, such that this should be 61. That should be 61. Okay. We cannot reduce that 61, but let's take a look. Okay, let's take a look. Suppose I want to try to reduce that 61. 61 over 100. 61 over 100. Convert that to fraction. You see, it's still 61 over 100. It means that fraction already in simplest form. Okay, it means that fraction already in simplest form. Okay, so I just leave it like that. Now then, how about probability of getting not A, so outside of A, but in B? Outside of A, but in B. The one outside of A, but in B refers to this region here. Let me use another color. Yeah. Outside of A, but inside of B. It's intersection, right? Okay. So it has to be outside of A, first of all, and at the same time, it has to be inside of B. So it refers to this 14 and 3. There are 17 elements. There are 17 elements outside of A and at the same time inside of B. So that will be 14 plus 3, that's 17 over 100. That's the simplest form. Part E. How about probability of selecting from B or? Now, because it's an or, then as long as you shade it once, you count it in. In B or outside of C. Outside of C refers to this is outside of C, this is outside of C, this is outside of C, this is outside of C. Now, the thing is, because it's an or, then as long as it satisfies one of the requirements, in other words, as long as you shade it or color it at least once, you already count it in. Okay, so let me count the one in B first. The one in B, 10 plus 14 plus 5 plus 3 plus the one outside of C. The one outside of C are 23 plus 16 and 10, but we already counted 10, and 14, which we already count also. Now then I will add this. I get 71 over 100. So again, what my question here is more about, if you see this notation, do you know what it means? And can you perform computation based on that? Okay. For those students who are well trained, they see this question very easy. But students who are not well trained, then they get confused. What does the line at the top of the letter mean? It is a complement. A bar means complement of A, basically outside of A. Okay, so let's look back from last week. Where's my notes from last week? Give me a second, let me look for it. I want to make sure that I covered that last week though. From last week. Oh, no, it's not from, it's not from last week, but it's from the lesson 3. It's from lesson 3. Remember I said that I assume you watched lesson 3 already, right? Okay. So it's from your lesson 3. If you watch lesson 3, then you see that that bar notation means complement, means outside of A. Now, part F, probability of intersection, not A and not B. Outside of A and at the same time outside of B. Let's see the ones outside of A first. Outside of A are this number of people. These are the number of people outside of A. Okay. And outside of B, these are the people, the number of people outside of B. Now, because that's intersection means it has to satisfy both requirements. To satisfy both requirements, it is signified by shaded twice. Now, the one shaded twice, they are 22. That's the one outside of A, outside of B, but in C, plus outside of A, outside of B, outside of C. Okay, the one I double color basically. Okay, then compute. This is 45 over 100, which means if I reduce by 5, this is 9 over 20. Okay. By the way, that A bar notation is the notation I already used earlier though. Okay, that's the bar notation we already used earlier, right? Okay, so somehow I thought you already know it. Anyway, yeah, but that's what bar means, outside of, complement of. Now then part G, let me erase the shading first, otherwise I get confused with the next question. What is the probability of selecting outside of B? Outside of B are this guy, this guy, this guy, this guy outside of B, or outside of C. Outside of C are this guy, this guy, this guy, this guy are outside of C. Now, because it's an or, then it just needs to satisfy at least one of the requirement. It just needs to satisfy, it just need to be colored at least once. So 22 plus 7 plus 16 plus 23. Those are people, the number of people outside of B, plus the number of people outside of C. The number of people outside of C, 23, I already counted. 16, I already counted. 10, 14. over 100. That's 92 over 100. I can reduce by 4, I believe. That's 23 over 25. Okay, now that's the 3 circles case. But again, this is more into, do you understand what those notation means? That's for the Venn diagram. Now, the next one is, how about computing probability with contingency table? Let me go on to the last part of today's lessons, today's discussion. Let's take a look on a contingency table. What is a contingency table, Thomas? A contingency table looks like this. Let me screenshot that for you. Now, this is a contingency table. That's a contingency table. Okay, that's a contingency table. Let me give you the better picture. Give me a second. So that you can see the question also. So this is a contingency table with the context included. Okay, so it shows describes the following contingency tables. Table describes the distribution of levels of technical writing expertise among NLAC students according to their field of study. Now, first complete the following contingency table. Okay, I need you to copy this table down and then add this, get the total, get the total. So these numbers here is the sum, that's the sum, that's the sum, that's the sum, and this is the sum, this is the sum, this is the sum. Now, this number that you get here will be the sum along this line, which is supposed to be the sum along this line. Okay, now let me ask you to do that. Let me ask you to do that. It should take you like around 3 minutes from now. Okay, please do that. Get the copy and then get the sum. Maybe 5 minutes. I'll give you 5 minutes. Oh, I'm sorry. I talked so much already. Oh, I'm sorry. My bad. So what I need to do? After you add this here, you get these numbers, right? Okay. You add this, you get this number. But before you go on, also do the following. You also add this one to get this, add this to get this, add this to get this. Now add this one also, make sure that you also get the same number, just in case you miscompute anything. Okay, now that's one. Second, when we compute the probability here, the instructions are, why I erase everything? Duh, silly things. The instruction was, the instruction is do it in 4 decimal places. Leave your answer in 4 decimal places. Now, so part A, what is the probability of selecting a non-expert level? Means outside of expert. The notation is probability of expert with bar on the top. Now, there are 2 ways to compute this. The first one is you compute those who are not expert. So I add all of this here, divided by 262. Okay, that's what I did in the first method. The second method is by knowing that probability of an event plus probability of not that event supposed to be 1. Okay, therefore, consequently, to compute the probability of not an event outside of A is the same to 1 minus probability of that event. Now, that's the second method I use to compute the second way. Okay, the second way is 1 minus probability of expert, which is 81 over 262. That's 0.6908. Okay, you should get the same answer. Part B, find the probability of selecting a beginner level with STEM major. Beginner level with STEM major. So the one in the beginner level and STEM major will refer to this one, right? There are 7 of them. 7 out of 262. So this will be 7 over 262. That is 0.02671. So to 4 decimal places. I stop there. Beginner level with STEM major. Part C. The probability of selecting a social science major, probability of social science or intermediate level. Social science or intermediate level. Let's see. Social science refers to everybody here. Okay. Or intermediate level. Or intermediate level, everybody here. Oops. Oh, that's not a good color. Let me use this one. Okay. Now, do not just add 138 plus 70. No, don't just add 138 plus 70. Why? Notice that in that 138, you already include 38, right? And in this 70, you already also include that 38. In other words, that 138 and that 70, if you add them, you would have double count 38. Okay, so the proper way to do that is actually the following. How many social science people? How many social science people? 138. How many people with intermediate level expertise? There are 70. How many people double counted? 38. So I subtract that once so that we count it only once over 262. That's how we will do it. Okay. Now, of course, you can also do it this way. You can also do it this way. Let me erase this. You can also add all these numbers here. You add social science, this guy, this guy, this guy, this guy, plus intermediate, this guy, this guy. So you add those 6 numbers. You will get the same number. You will get the same result with the technique I had earlier. Okay. Then when I compute this, let me do it below. I get 170 over 262, whose decimal is 0.64885. So it will be 89. I say that before in my lesson 3 that when you write a decimal without integer part to the left of the decimal point, you need to write that leading 0. You need to write that leading 0. I penalize half point every time I say it. Every time I don't see that leading 0, if you're supposed to have leading 0 and you don't have it, then I will penalize half point. Okay, so please, please, please do that leading 0. Okay, go on. Find the probability of selecting an interdisciplinary major outside of no expertise. Okay. Probability of selecting interdisciplinary and outside of no expertise. Outside of no expertise. Outside of no expertise. So it refers to those people who are in indisciplinary and outside of non. Outside of non refers to this. Now, then what numbers, how many people shaded twice? Because it is an n, right? It is an n. So how many people shaded twice? Who are the people shaded twice? Those who are in indisciplinary but has some expertise. Okay, that would be 9 plus 21 plus 14 over 262. That's 44 over 262. That is 0.16794. So 4 decimal places, I stop there. And last one, what is the probability of selecting a non-STEM outside of STEM with no technical expertise at all? Outside of STEM, okay, outside of STEM, but no technical expertise at all. Outside of STEM refers to this group here. This is outside of STEM. But that person needs to have no technical expertise. Because it is an and, then you take the one double shaded. In this case, it will be 20 plus 15 over 262. 35 over 262, that is 0.13358, 1336. Okay, now this is what we will do today. I actually planning to do one more problem regarding this contingency table. But let me just ask you to start working on my old test one, and you will see a lot of, pretty much in most of all my old test one, you will have this type of questions, the one I go over today, most of them. So if you masters whatever I go over with you today, you should be able to get already 70 points, at least 70 points already, maybe even 80 if you masters all of them. Okay, now next week, what we will do, that has something to do with your lesson 4. So please make sure you watch lesson 4 before next week. Okay, don't come to class without watching anything. See, I do what we call flip class. Flip class means that the learning, the lecture part is done outside of class, and inside of class we do more exercise. Okay. Okay. The lecture part you can watch at your free time. Okay. You're supposed to study outside of class anyway, right? So let's just do it that way. We already have that recording, so I don't need to repeat those again in class. Okay. But I go over problems in class so that if you have question, you can ask me right away. Okay. Now, so please watch lesson 4, and next week we will continue with the remaining material for your test 1. Okay, we will have the situation of, let me give you the scratch work of what you will see next week. Okay, we will do this. Okay. What if we select more than one element? Or another one is, what if we don't have, Venn diagram, we are not given Venn diagram, or contingency table? Then at that time we need to use formula. Okay, and what if we need to compute what we call, this is actually related to at least one element, to compute the probability of at least one, which is actually covered a little bit in our lesson 3. So make sure you watch lesson 3 though. Don't just skip to lesson 4. That's not how I designed this class. Okay, you cannot just say, oh, you know what, I skip lesson 3, I go on to lesson 4, and I should be okay. No, this is a math class. Okay, so the next floor, the next lesson is built up on the previous lesson. Okay, you cannot build the 4th floor without building the 3rd floor first. Okay, we cannot understand lesson 4 without doing lesson 3 first. Okay, so please watch that lesson 3. So part of your lesson 3 will still be discussed next week. Okay, the probability of at least, but that's because we already discussed this in lesson 3, not extensively, not a lot, just a little bit, but I believe it is also discussed again in lesson 4. So please make sure you watch lesson 3 and lesson 4. Okay, last one. You have a homework due tomorrow. Quiz 1, I believe, due tomorrow. Okay, don't forget that. Please do it. Quiz 1 due tomorrow. And I plan to post new quiz either tonight or tomorrow that we'll do next week. Okay, so don't wait until tomorrow last minute and start doing that. No. But Thomas, what happened if I don't have printer? I already went over that before with you. If you don't have printer, then you write it on a piece of paper. Okay, and submit it. What happened if I don't have scanner, Thomas? Then use your smartphone. What if I don't have smartphone? Then how did you follow my class to start with? You don't have anything. You don't even know. You don't even have access to my lecture then. Okay, do something. Okay, do something. Okay, we did quiz 0 already. So this is the time for quiz 1. Okay, quiz 1 due tomorrow before the midnight. And again, I do not take late homework. Okay, if you send it to me by email, tell me something wrong with my whatever, I will just ignore it. I delete it right away. Okay, no, I will not accept late homework. Okay, your quiz 0 is already an experiment tool where you learn how to submit your quiz. Okay, now that's for today. See you then on next week with your lesson 4 already watched. Okay, and don't forget you have a quiz due tomorrow evening. Do it as soon as possible. It's doable since last week. Okay, bye-bye.